In this video, I want to talk about input validation and type conversion. So inside of our final projects, in the demo class app, I've got the movie rating app. Inside of your project, you've got some other kind of data where you're collecting input from the user and storing it into your database. And so we want to validate these inputs, and then we want to do a type conversion if necessary. So validation means that we're checking to make sure that it meets our constraints for whatever the input is. So for instance, our rating, our system is designed to be a rating between 1 and 5. So we shouldn't be able to put in 0, or we shouldn't be able to put in -10 or 100. So the validation is us applying those constraints to check the input before we actually submit the form. The other piece of this puzzle is type conversion. So generally what you get back from these input elements when you check their value is a string value. So that's fine for the movie title, which should be a string, but that's not okay for our rating or year released, which are actually numbers. So we want to take the string value that we're getting here, convert it to a number before we send it off to our database. And the reason we want to do that is that when we store this rating as a string instead of a number, the sorting features, like sorting by rating, can break, or the filtering features where we want to say like, oh, this must be greater than 3, like we only want to get movies that have a rating of 4 or 5. If we store some of those movies with a string rating and some with a number rating, that filter is going to break. So to follow along, you can use any version of the movie rating app that has the MovieForm in it. I have a starter file here that is the web version, so it's not the Electron version. It'd just be a little bit easier to set up and test, but this will all work inside of that Electron environment. So you can grab the starter files, make sure that you install, and then run npm run start to get it running, which I've done here. And the first thing that I want to do is go into my on movie submit, and I'm going to disable the on submit here. So just a quick refresher, the MovieForm, we're using that on the add and edit pages. So add movie puts the MovieForm onto the page, and edit movie puts the MovieForm onto the page. So it's a reusable component that we're using in these two different contexts, which means that our database logic for adding a new movie to the database or editing a movie, we don't want to put that into this MovieForm because the database logic is context dependent. Are we on the add page or are we on the edit page? So the way we solved this was to pass in a function as a prop to our MovieForm, which means that our add movie can go ahead and call the logic for saving a movie or saving a new movie to the database, and our edit movie can go ahead and run the editing of a movie, so save some changes to an existing movie. And so the difference between these two lines that we were just looking at is the edit movie passes in a movie ID to our hook so that we can go ahead and look up that movie ID and save it, and our add movie here doesn't, which allows our hook to go ahead and save a new movie. So all we're doing here is making sure that this on submit that's being passed into our MovieForm is not being called. So we will re-enable this later, but this will just allow us to test the submit button without actually filling our database with a bunch of information. So what I want to do first is show you how to print out the type of these different fields that we have. So we have the title, the rating, and release year, which are being displayed in these inputs here on the page. Here we go. Here's the text input for the title, the number input for the rating, and the number input for the year. So I just want to print out the state that is associated with those inputs, which we created here, the title, the rating, release year. So I'm going to use a template string and say the title is title, and its type is, and we'll use the type of operator in JavaScript, which will print out what type of variable this is, or what data type this variable is. So we should see the title is, whatever we put into that field. And hopefully what we'll see for title is that the type is a string. I'm going to copy and paste this and go ahead and replace this with rating. And then do the same thing here with release year. So anytime we hit the save button, we should see all three of these things printing out here. So if I flip back to the browser and I open up my console so that I can see things printing out, and I'm just going to hit save before typing anything in here. So we can see the title is a blank string here, the rating is 3, and the release year is 2020. So that matches what we're seeing here, and the types are matching initially. We can see a string, we can see a number, we can see a number. So this kind of matches our expectations. So far, none of this information has been manipulated by the form on the page. Because if we look at our code here, we are just setting our initial state for our title to be an empty string, and our initial state for our rating to be 3, and our initial state for the year to be 2020. So far, nothing has happened with our form in terms of those inputs. So then what I'm going to do is go back to the form here, and I'm going to put in a title and a rating and change the year and hit save and see we've got our title and it's a string, but now our rating has been changed to be a string and our release year has been changed to be a string. So where that's happening is here. When we set our title, set our rating, set our release year, we are grabbing the value from our input field. And that value is generally going to be a string as opposed to a number. So what we need to do is take charge of this and do two things. One, we need to run validation logic to ensure that our inputs are valid, that they meet certain constraints, and we need to do type conversion. Make a little to-do list for us here. So we need to do both of those, and if something fails in those steps, we don't want to run our submit. We want to display an error message. So we've already got from the initial version of this application that we built a piece of state here for error message that is being then displayed using an error message component in the form. So if we used set error message, inside of our onMovie submit, and then reran this, we would see that error message show up here. So this is our generic place to dump an error message related to one of these fields. So if our validation logic fails for any of those fields, or our type conversion fails for the rating or release year, we'll display an error message and prevent ourselves from actually submitting so that the user can fix that error and try submitting again. So we can get started and do some initial validation here. So one easy check for us to do is to make sure that someone has actually entered something for the title, the rating, and the release year. And the way that we can do that is just check our state variables here. So if the title is an empty string, they haven't entered anything. So we can go ahead and set error message. Please enter a title, and then return. So the return here means that we're going to stop anything else from executing that's inside of this function. So even if we had this onSubmit uncommented, then onSubmit would never be reached if our title is blank. So I'm going to leave that commented out. I'm going to get rid of this error message. And maybe what we'll do in the meantime is add a line here to simulate what it would be, simulate what would happen here if we got through all of the error checking. let's say successfully saved movie. So if I flip back to the browser, if I type something in, we should see successfully saved movie printing out. And if I remove this and try and save it, we should see an error message popping up. And no successfully saved is printing out down here. So this is a really simple validation check. We're just going to make sure that none of those inputs are blank, and we can do that in the same format. So actually, I'm just going to copy and paste this chunk of code. And say rating and release year. So with this, we have implemented a very simple validation check to make sure that none of those fields are empty, which means that I should be able to get something working here. Successfully saved movie. But then if I go ahead and delete any of these fields, we should get an error message for that field. So let me delete the rating. Please enter a rating. Delete the year. Please enter a release year. One thing you'll note is that if I were to leave all of these off and try and save, we're not actually displaying an error message for each of these fields. We are just displaying the first error message we encounter. So someone would then, fix this, hit save, get the next error message. This isn't the best user interface. Like a better one that we could build, and maybe we'll do that in this video if we have time, is to display multiple error messages here. Maybe display an error message under each of these inputs. So we would have the movie title error below that input, the rating error below that input, the release year error below this input, and that would allow us to display all of the errors all at once. But this simple version will work. Like we're still functional here. We're doing our validation. We're giving the user some information. It just could be improved later if we want. Okay, so our first validation check is good. What we want to do now is do some type conversion and then do some more validation checks. So the title, all we need to do is make sure that that is not an empty string. So if they've typed something in here, they're good. We've got a valid title and we can save it. The rating and release year, we saw these are now strings as soon as the user has typed something in the form. So we want to convert them to numbers before we actually save them to our database. And for both of these, we can do some validation logic after we have it as a number. Like our rating here, we need to make sure that this is a number between 1 and 5. So we'll convert it to a number, we'll do our type conversion, and then we'll do some more validation. And same thing for release year. This is a number. We know that it has to be at least 0 or greater. I mean, we could make that more fine-tuned. Like we could look for the first release year of a movie and make sure that it's a number greater than that first release year of a movie. But for our purposes, we'll just say that it has to be 0 or greater here for the release year. Okay, so let's put a comment in here. Make sure our inputs aren't empty. Let's convert rating to a number and validate that it is between 1 and 5. So we have a couple of options when we want to convert from a string to a number. We can use the number.parseInt function. We can use the number.parseFloat function, and we can actually use the number constructor. So any of these three will work. ParseInt is for specifically converting something to an integer. ParseFloat is for converting something to a floating point number, and number is will do both of these. It'll basically convert it to the matching type. So if we pass an integer string into number, we will get an integer back. But if we pass something that has a decimal place, we'll get a floating point number back. So just for reference, I'll put a few in here so that we can see it working. So console log, we're going to call number, parse int. This takes two things. So the first thing is it takes a string. So let's do the string 1, and then radix is the base that you want to use for converting this number. And in most cases, you are going to want base 10 because that's how we count. So if I go ahead and parse int here, whoops, we're going to have to enter a title before we can see that print out. So parse int is giving us back 1. So we gave it a string with 1, we got back the number 1. Parse float here, if we pass in, let's do a couple. Let's say that they typed in a bunch of letters, and let's do one where they typed in a decimal place. So if we flip back here, type in a test movie, see it printing out, we can see that we get 1, 1, and nan, which stands for not a number. So this one converts to 1. This is what we expect. This one converts to 1. So let me add these here as a comment. So our parse int here, 1 turns to 1, all good. 1.5 turns to 1, which is maybe a little surprising. Maybe you'd expect this to fail because we gave it something that's not an integer, but it'll take what we give it and then convert it to an integer if it is something that can be compatibly converted to an integer. So here we just lose the decimal component and get an integer back. Here we are getting not a number, which is a specific value that tells us that this thing that we passed in was not a number. So this will fail, and we can check that it's not a number. So we can check for this value. So this is great. This might be what we would want to reach for here for rating and release year, except that I don't like that this happens. So if the user types in something to our field, like 5.5, thinking that they are allowed to type in decimal places, and they hit save, we would be sending to the database the number 5, and we would not be telling the user, hey, something went wrong. You can't store a decimal place. So what I want to do instead is use the number constructor instead of parse int. So if we do that and run this, we should see not a number here. We should see 1, but we should get 1.5 out of this line of code. So here we go, 1, 1.5, and not a number. So we are going to use this number conversion over parse int because we will then be able to check, hey, is this number that we got from the user an integer? Is it 1, 2, 3, 4, or 5? And if it's not an integer, then we can give them a message like, hey, you can only enter whole numbers between 1 through 5. So this will allow us to build a slightly better user interface over just doing a parse int. Okay, so all of this test code, we can comment this out. This is just so that we understand what we're doing with number and parse int. And what we want to do is get the rating as num. So we're creating a new variable here where we are taking our rating state variable and converting it to a number. So it'll be something like 1, 1.5, or not a number. So once we've done this conversion, then we want to do some type check. We want to do some additional checks here to like isolate these different situations. This one is fine if we've got an integer, as long as it's between 1 and 5. This one, we want to display a message to say, hey, make sure you put an integer in. or make sure you put a whole number in, and this one we want to make sure to say like, hey, you got to type in a number. So let's do number dot is nan. So this function allows us to pass in a value, and it will tell us true or false. Is this thing not a number? So is it this value, nan? So if it is, then we can go ahead and set an error message to say, please enter a whole number between 1 and 5. Or a whole number rating between 1 and 5. And then we can also do a similar pattern here where we're going to return to mean we're going to stop anything after this point because we know we have something that's invalid. We can't continue. So if we come back here, fill in a title, remove the rating, give it a save. Ah, that is getting caught by our empty string check. Let's see if we can, you know what? Because we set this thing to be an input of type number, we can't actually type any letters in here. I could type a period. Let's see if that gives us, nope. Okay, so one thing that is useful to point out is that these types that we apply here allow us to put some constraints in the browser, but we can't 100% rely on those because a user could manipulate the HTML and inject something into our page with kind of malicious intent. So usually you'd want to do these type checks on your server. We're building our application without a server. So what we can do here to just try to handle this situation where we're getting not a number is let's disable the type of number temporarily. And if I come back here and now I can type in gibberish, we can see we're getting that error. Please enter a whole number rating between 1 and 5. So as soon as we verify that that logic works, we can turn our type of number back on, which will then enforce that the browser is not going to let the user type in any letters. Ooh, somehow I got an E for exponent. So we're allowed to type in E and decimal places. Okay, so we've got the not a number, and what we want to do is handle situations like 5.5 and 10 and -10. So if we come back to our code, maybe this will be our catch-all error for when it's not a number and when it is a number with a decimal place. So what we can do here is say that this error message should be displayed if that rating is not a number, or if that rating is a number with a decimal place. So this line of code is maybe a little confusing if you haven't seen the modulus operator before. So this allows us to get the remainder from doing division. So if we take a number and we divide it by 1, this will tell us if there's any remainder. So any number that's an integer, you can divide by 1 evenly, right? 1 divided by 1, 2 divided by 1, 5 divided by 1. But if we divide something that has a decimal place, like 5.5 divided by 1, we're going to have something left over in that division. So here all we're doing is we're dividing by 1, getting the remainder, and checking to see if it's not 0. So if it's not 0, then we know that this thing isn't a whole number. So let's give this a test and see if it works. Come back here, put a title in, try 5.5. Hit save, and it's catching on that error to notice that that is not a whole number. So we've got our check here for them typing in non-numbers. We've got our check for them typing in floating point numbers. So let's, now that we know that we've got a number version of what they typed in, check to make sure that it's within the right range. So after we've done this check, we know that if we get to this line of code that this error has not occurred, because return would kick us out of the function. So what we can do here is use rating as number. We know that it's a number, and we can say if it is less than 1 or the rating as number is greater than 5, we can do a similar error message print out here. So let's say please enter a whole number rating between 1 and 5. Come back here, try typing in 100, put in a title so that that test passes. Please enter a whole number between 1 and 5. Let's try negative 100. Please enter a whole number between 1 and 5. And then as soon as we type in one of those values between 1 and 5, successfully saved movie. So we've done our validation on that rating field. You know, looking at this, initially I thought that we would want to display a different message if the rating was out of bounds versus if the rating was not a number or the rating was not a whole number. But since we can get away with just displaying the same error message, what we can do is refactor this to just throw these conditions up here as well. So I'm going to take the check for less than 1 and greater than 5, put them into our if statement up here, and we have a single line that does our checking to ensure that it's not a number, it is an integer, it is not less than 1, it is not greater than 5. If any of those were true, then we would print out an error message and we'd stop doing any more of our checking or submitting whatever we have after this if statement. So let's just do a quick check, make sure that that works. Come back to the browser, try putting in a negative number, got an error, try putting in a decimal place. Whoops, let's do 3.5 or 4.5 here. Cool, still got that error. Big number, and then number that's valid. And we see successfully saved movie. One thing that we're also seeing is that this error is not cleared when we go hit the save button. So even though we eventually got to a valid value, our error is still here. So what we can do is at the top of our error checking, our validation is clear the error message. So we could set it to an empty string, we could set it to null. Either of those would work in this situation. Undefined would also work. So we're just getting rid of the error message and then showing a new one if there is an error. So with that tweak in there, should say, please enter a title, and then as soon as we type something, that error message should go away. Same thing here, if we do 3.5, and then we go back to 3, that error message should go away. So then we want to do a very similar thing for our rating, for our release year, which also has to be an integer. So we got to do this NaN check. We have to do this integer check. And then for the constraints here, we're just going to make sure that the release year is a positive it's not a negative number. So it's 0 or greater. So we can do year as num. And I'm just going to copy this line and put our year as num here. And here, if our year as num is less than is less than 0, we're going to go ahead and set an error message. Please enter a valid year or a valid release year. And if we're in an error state, then we want to return so that we don't do our submission logic down at the bottom here. So let's try this again. So if it's valid, we should be able to submit. Good. If it is a negative number, please enter a valid release year. And we've got type of number here, so I can't actually type in any letters. So to test out that logic, I could come in and disable type number on this input, come back, and now I should be able to type some letters and see that this catches for things that are not a number. Yes, please enter a valid release year, put in something, and it's valid. So then instead of console logging successfully saved movie, we can get rid of that and turn our on submit back on. So this kicks off our logic to actually put something in the database. The thing that we have to change here, title is fine, but now the variable that we want to use here is our number version of our rating. So it should be rating as num, release, and year as num here. So now what I should do is open up my Firebase console. And we are, I'm just going to find which user I'm under. So I've got a movie called Test Movie with 4 stars. Is that this user? No, it's not this user. Nope. Got a few users in my database from testing. Okay, here we go. So I'm going to verify that this is the right user. I could do that by printing out my user ID. Actually, what I'll do is open up my components tree here and go to my app where I have my user state. And if I look at this, I should be able to see my ID. Here we go. S78LB. S78LB. So I've got the right user here. This user is the one that we're looking at. So I'm just going to have their movie collection open. And let's look at what happens if we add a movie without our validation and if we add a movie with our validation. So let's add a movie here with our validation. So let's call it valid test movie. Give it a rating of 5 and 2019. And hit save, and check out our data here. So this is stored with a rating of 5, release year of 2019, and valid test movie. And this is a string, this is a number, this is a number. Looks great. So this is what we built with our latest change. And I'm going to get rid of this other movie that we've got here under this test account. So I'll delete that. And what I want to do is quickly Control Z back to what we had before, where we were just dumping in our rating and our release year directly using those state variables that we got that were strings. So test invalid movie, give it a rating of 1, 1990, hit save. And check it out here. So we can see that the rating was stored as a string, the release here as a string, the title as a string. So if we had asked our database to do any kind of sorting or filtering on rating or release year without doing our type conversion and making sure that these are stored as numbers, we could get some wonky results because strings and numbers don't filter and sort the same way. So with that change, we should be good on our form here. I'm going to redo the change that we had that forced things to be saved in the right format. And before we leave this project, so I think because this video has already taken a bit of time, I don't want to go into displaying multiple error messages on the page. But to leave you with a hint for how you could do that type of thing, instead of storing, let's take our rating here. We're storing it as a single value here. Instead of storing it as a single value, we can store it as an object that has a value and an error component. So if we store it with a value and an error, that means that for each state variable, we can give it its own error message that should print out. So when we go to display error messages on the page, we would check rating.error to see if there is one, and title.error and release here.error. And then we can put those on the page, and we can put them into multiple elements on the page. So you could have like a div that goes below your rating that you use to print out the rating.error, if there is one. So that should give you enough of a hint to go in that direction if you want to build something like that into your page. At minimum, you should definitely be doing this type checking and conversion, this validation and type conversion in your project. And what you want to do your sanity checks is print out your type of your different state variables before you actually submit them. So you can do that in JavaScript. And then to make sure that stuff is actually being saved properly in your database, go in here, add values to all the fields, and then check it in your database to make sure that each field is showing up with the right type that you expect. So with that, you should be set to do your validation and type checking in your final projects.